Okay, so just to quickly recap the properties of logs that we were doing, the properties of logs are the reverse of properties of exponents. So when we're looking at properties of exponents, we know that if we have a to the third times a to the second, what we do is we add the exponents, right? A to the 3 plus 2. That is actually exactly what this first property is saying, except I flipped the two sides around. But see how these two exponents are being added? That is because their bases are being multiplied, right? When a to the third is multiplied by a to the second, we add the exponents. So when you have a times b, their exponents, or their logs, are added. Logs are really exponents. So all you have to keep in mind is when we take the log of these two things multiplied together, we're really talking about the exponent of these two things multiplied together. So we add the two exponents. All right, it's just the exponent property in reverse. So when we took like a to the fifth over a to the second, when the two things were divided, like a divided by b, we subtracted the exponents. That's what this is saying. We're subtracting the log of a minus the log of b. And since logs are really exponents, it's really just saying we're subtracting the exponents. And then the last one was when you had the a to the fifth squared. What we did is we multiplied the exponents. So if you have log of a to the c, something with a power, you can take that power and bring it out front, because what you're really doing is you're multiplying the log of a, which is its exponent, times c. All right, so exponent times exponent as opposed to power to a power. So these properties are really the properties of exponents in reverse, and they are true for exactly the same reasons. So when we're doing these problems out, there's two ways that I can ask you to do this. One is to put things together, and the other is to take things apart. When you're putting things together, the first thing you want to do is you want to get rid of any numbers that are in front. So I'm not going to move this, but I am going to move this 3. I'm not going to deal with the minus sign. I'll deal with that at the end. That 3, by this third property, can be written as 2 to the third. And then the 2 that's here can be written as log of 10 squared. So that third property is actually the first thing I do when I'm putting these together. I get rid of any numbers in front. And the reason we do that is because these properties only work if there's no numbers in front of them. You can't do like log of a plus 2 log of b. So in order to do these first two properties, we have to get rid of the numbers in the front. So we use that third property to do it. Now we use properties 1 and 2, and I try to do them at the same time, because anything that's added is the first one, and anything that's subtracted is the second one. So basically anything that's added is going to get multiplied together, the bases are, and anything that's subtracted, that base is going to get divided. In other words, the positive numbers are going to go on the top, so 16 will go on the top, 5 will go on the top, multiplied, and 10 squared will go on the top, and on the bottom will be 2 to the third. Anything that's negative goes on the bottom. So before I actually do this out, this is 16 times 5, that's 80 times 100 divided by 8. That comes out pretty simple actually, because the 8's are going to cancel, and I'm going to get 10 times 100, which is 1,000. And the log of 1,000, remember, since there's no number here, I assume this number is a 10. The power of 10, that equals 1,000, that's a question mark, sorry, is the third power, right? Powers of 10, you just count how many zeros there are, and that's the power. So this would be the third power. Okay, so 2 steps here. First thing I did was I moved the numbers that were in front and made them exponents. Second thing I did is all the positives got multiplied on the top. All the negatives got moved to the bottom so that they were division. When I expand, I'm going the other direction. So I'm going to first undo the first and second properties. I'm going to turn all of these into log of something plus log of something minus log of something. And then the second part I'm going to do is deal with the exponents on those numbers. So I'm going in reverse. So I have the log of p squared. Now I have all of this stuff divided. When I separate these, the division is going to turn into subtraction. That is property number 2. My division, when I put it as 2 separate logs, turns into a subtraction. So log of r to the third And I also am going to do minus log of the square root of q. I'm going to write that as q to the 1/2 because that'll make it easier to do my next step. So, and now I've got it all separated. Anything that was on the top is positive. Anything that was on the bottom turns into a minus. My second step is the first one that I did when I was putting them together, which is to get rid of these numbers that are exponents. I make this 2 log p minus 3 log r minus 1/2 log q. And then that's my answer. That's as expanded as I can get. The expansion means you separate it into all different log terms, and then you move the powers out front. All right, so using that information or those properties, I'm going to be able to take these things and write my answers in terms of r's and s's. So this looks more complicated than it is. First of all, I know that the log base 8 of 3 is r, and the log base 8 of 5 is s. So what I want to do is I want to turn this into log base 8 of 3's and log base 8 of 5's. First thing I notice here is there's a 1 divided by 3. So I could write that as log base 8 of 1 minus log base 8 of 3. In other words, I can take this and I can split it up into 2 separate logs. The reason that helps is because the log base 8 of 1, the power of 8 that equals 1, I don't really need to know anything about r's and s's to figure that out, because the power of anything that equals 1 is the 0th power. And then I have the log base 8 of 3. Well, I know what that is. That's r. So I have 0 minus that whole thing, which is r. So negative r would be my answer. Okay, if that one didn't make sense to you, watch this a couple more times, you'll start to see what I'm doing here. So this one I'm going to separate. Log base 8 of 3 minus log base 8 of 25. 25 is a little bit tricky because 25 is not one of the numbers I have here. I have 3's and 5's. But 25 is the same as 5 squared. So I'm going to turn that into log base 8 of 5 squared. So log base 8 of 3 minus, now this thing I could turn into 2 times the log base 8 of 5. The reason I did that is because the log base 8 of 3, I know what that is, that's r. And then this thing I know is s, so minus 2s. All right, these are tricky. Again, the idea with these is just to kind of try to rewrite everything in terms of r's and s's. So now that I saw that this was 3 divided by 5 squared, this one I'm going to split into 3's and 5's by thinking about what 75 is. 75 is 3 times 25, right? So I could split that into a 3 and a 25, or a 5 squared. Because 3 times 5 squared is 75. So this is really similar to the one I just did. It's just a plus instead of a minus. So this thing right here is r. This thing right here is not s squared, because in order to actually substitute, I would need to move that 2. And now I see that this whole thing right here is s. So my answer is r plus 2s. There's my answer. And I'm running out of space here. This last one would be the log base 8 of 3 minus the log base 8 of 64. This thing is r. This one is not r or s, but the power of 8 that equals 64 is actually a number I can figure out. 8 to the what equals 64? That would just be 2. So this would just turn into r minus 2. All right, I'm going to skip over this one because it's kind of the same thing, and I'll do one like this when I get back. I just wanted to kind of show you how you can use this to manipulate letters, basically. So using property of logs, you can kind of like move things around and get different versions of answers. All right, so now that I've thrown some really tricky problems at you, I want to do something a little bit simpler, and that is to talk about the number e. Now on your calculator, there is an E button. I opened up my calculator here, and you can see that if I hit second division sign, there's an E. When I hit enter, it gives me a number. It's about 2.7. There's a second way to get E, in case you're wondering. If I hit second ln, we haven't talked about ln, it gives me E to a power. It's the same thing. you can see that this lowercase letter e is about 2.7. And you've probably seen this number before, but you may not know exactly what it represents. Its actual definition is this limit statement. And this limit statement won't be fully understandable to you until calculus, but it basically is saying, take a really big number for n and do 1 plus 1 over that, and then to the n power. So if n is 1,000, for example, I'm going to do, let's see, in parentheses, 1 plus 1 over 1,000. And then outside the parentheses, I'm going to do to the 1,000th power. 1,000. Enter. And look at how close that comes to the actual value of e. If I were to do 10,000, I would get a lot closer. 1,000,000, 2,000,000, 1,000,000,000, right? You can go bigger and bigger and bigger. And what this limit is saying is if n were infinitely large, I would actually get this exact number. Now that's a little bit weird because why would you know that you'd get this exact number? It has to do with the fact that e is very much like pi. It's an irrational number that you will see a lot in calc, but you will also see it in pre-calc when we talk about exponential growth and things that compound continuously. So this is an irrational number, meaning that it never ends and it never repeats. Those are the first 5 decimal places, but there are obviously infinitely many of them, and they've calculated a lot of decimal places at this point now that they have calculators and can do them really quickly. Okay, we will get a lot more into what this actually means, but what I want you to know is that there's a log devoted to this number. So I told you that when you see like the log of 100, it means log base 10. That's what's called a common log. We also have what's called a natural log. So when you see ln, that's referring to another type of log. It's a natural log. ln is the same as a log with a base of e. So this is basically a shorthand notation for saying log base e of this number. Now, log base e, log base 2.7 doesn't make a whole lot of sense unless this happens to be a power of e right here. This is saying what power of e gives you e. So even though you don't know much about e, you know that the power of e that gives you e is the first power, right? If I ask you e to the what equals e, the answer is 1. If I ask you what power of e gives you e squared, which is what this one's asking, then that would be 2. Right? The power of e that gives you e squared is 2. So when you see this ln, it's really just saying log with a base of e. This is saying log with a base of e of 1 over e. The power of e that equals 1 over e, that would be the negative first power, because e to the negative first would give you 1 over e. And the power of e that gives you that, right? Well, remember square root is 1/2 power, so the power of e that gives you e to the 1/2 is the 1/2 power. So these actually come out fairly nicely just because they use the number e in them. All right, one more thing we can do with e's really quickly because I'm running out of time here. We can put these together using our regular properties. So I can put these together by first moving that number 2 up there and making that a 4. And then taking these and putting them, the subtractions and the additions turn into multiplications and divisions, right? So 3e to the 4th, I'll put the 12e on the bottom and the 2 squared on the top, just like we did with all these other properties. So ln's have the same properties that all these other things did. So when I multiply this out, that is 3 times 4, that's 12e to the 4th over 12e. The 12s cancel, and I'm left with the ln of e to the 4th over e to the 1st, which is e to the 3rd. And that is asking me what power of e gives me e to the 3rd. So even though I don't know much about e, I know that the power of e that gives me e to the 3rd is the 3rd power. That's it. All right, same thing here. I'm going to take the 2 and put it up there and make that a 9. And then I'm going to take all these terms and put them together. 36 on top, 9, 3 squared on the bottom, 24 on the bottom, 6e on the top. And I did some really quick division here because I ran out of time, but 36 and 24 are both divisible by 12. So this becomes 18e over 18. which turns into ln of e, which is what power of e gives you e, so the answer here is 1.